Hello, everyone, and welcome to St. Andrew's Institute of Technology and Management, Gurgaon, Delhi, NCR. St. Andrew's Institute of Technology and Management is the best college in India and it provides best placements and it follows the best industry education standards in the industry. It provides variety of courses from BTech, BCA, BBA and soon starting with MBA, law and architecture. This is the best college that you can get admission into. The subject that we study here is Principles of Software Engineering. Code is CSE 302F. This is a CSE 6 semester subject. The syllabus is in accordance with MDU University Rohtak. We'll be today studying all the design concepts like abstraction, refinement, modularity, software architecture, control hierarchy, structural partitioning, data structure, software procedure, and information hiding. I, Shalini from CSE department, shall take you forward. Abstraction. Abstraction is one of the most important principles in object oriented software engineering, and this is closely related to several other important concepts like encapsulation, inheritance, and polymorphism. See, abstraction, wherever we talk about object oriented programming, abstraction has an important role to play, right? And this also, I would say, it complements all other concepts of encapsulation, inheritance, and polymorphism. So whenever we'll do class and we'll make a class of that and we'll make an object of that, we will study this. We always find this concept abstraction in that. Abstraction is applied in the process of identifying software artifacts to model the problem domain, right? It is the process of reducing these objects to their essence such that only the necessary elements are represented. So it will reduce these objects to the essence that only the necessary element are represented and all the unnecessary element or the ones that are not required will be hidden. So abstraction, it defines an object in terms of its properties, functionality and interface and means of communicating with other objects. So these methods are used to reduce the complexity of the design and implementation process of software. So in that process, the designers define abstract object actors that are able to perform work, change their state and communicate with other actors. Right? The state of the object is encapsulated while the detailed data structures associated with the objects are kept behind the scenes. Now we talk about refinement. See, stepwise refinement is the idea that software is developed by moving through the level of abstraction, beginning at higher levels and incrementally refining the software through each level of abstraction, providing more detail at each increment. So the next level, so the first level, the second level, the third level, so the third level is more refined and more detailed compared to the second, and the second level is more defined and more detailed than the first. So with every step, so you refine more and more. At higher levels, the software is merely its design models. At lower level, there will be some code. At the lowest level, the software has been completely developed. So at the lower level, it will be like completely developed. At the early steps of the refinement process, the software engineer does not necessarily know how the software will perform what it needs to do. So this is determined at each successive refinement step as the design and the software is elaborated upon. So what will happen is that, so the next, if anything is not clear at step 1, we'll see if it is clear, if it gets clear to second step of refinement. If it is not, then we will see that if it is clear in third step of refinement. So all the thing that you're supposed to do and the work that you get to understand, you actually keep on moving from one step to the next and keep on refining them. So refinement can be seen as the complement of abstraction, right? Abstraction is concerned with hiding lower levels of detail. it moves from lower to higher levels, wherein refinement is the movement from higher levels of detail to lower levels, right? So in abstraction, you move from lower to higher, hiding the details, wherein in refinement, you move from higher to lower with more and more details coming up. So these are actually complementary to each other. Next, we come to control hierarchy. Control hierarchy is also called as the program structure. It basically represents the hierarchy of control. So whatever will happen in the control program structure, it will representing the hierarchy of control. So it describes hierarchy of control by omitting the procedural aspect, which covers sequence of processes, occurrence or order of decisions or repetition of operations, right? So the depth, the depth to which you proceed and the up till the width that you move, it indicates the number of levels of control and overall span of control. So you fan out a measure of the number of modules that are directly controlled by another module. So you know like which module is controlled by which another module, and it also gives you a direct control of the given modules, right? So the program structure is usually expressed as a simple hierarchy showing superordinate and subordinate. So the one on the top will be superordinate and the one on the lower one will be the subordinate. So if we look in this next figure, so there's a control module and then it has two submodules. So these two submodules will be under this control module. So the control module will be the one who will actually be guiding and it will have the power actually to like how to which module to control and which way to move and how, wherein these two submodules are independent of each other, wherein but they are being controlled by the the module on the top, that is a control module. Okay, next we come to software architecture. The architecture of a system describes its major components, their relationship, and how they interact with each other. Software architecture and design include several contributory factors such as business strategy, quality attributes, human dynamics, design, and IT environment. So, in architectural, non functional decisions are cast and separated by the functional requirements, or in design the functional requirements are accomplished. So what you do in architecture, you look at the non-functional decisions and you basically cast them and into various different functional requirements. So architectures it serves as a blueprint for a system. So whatever your system will, so your architecture will be actually be a blueprint. If I can say that, see, if you want to build a house also, then you have a blueprint of the house according to which you move. The city also has a blueprint, right? If anything like anything being planned out then there, so everyone has a blueprint. Similarly the architecture are also, in which all the non-functional requirements are the one that are being cast, right? So it provides an abstraction to manage the system complexity and establish a communication and coordination mechanism among components. Next, it defines a structured solution to meet all the technical and operational requirement. See, we are doing this designing, we are doing structural designing, so it should be clear to you. So everything is structured out in there. Architecture is also a structured solution, and it will meet all the technical and operational requirement, the non-functional one, and optimize the common quality attributes like performance and security. Right, so it will have all these requirements like the technical and operation will be met by this architecture, and this they will all be optimized into performance and security. Further, it involves a set of significant decisions about the organization related to software development, and each of these decisions can be considerable impact on quality. So what happens, it will have a set of significant decision about the organization related to the software development and how they have a considerable impact on quality, maintainability, performance, and the overall success of the final product. So what will decision will comprise of, it will have selection of structural elements and their interfaces by which the system is composed, behavior as specified in collaborations among those elements, composition of these structural and behavior elements into large subsystem, architectural decisions align with business objectives, architectural style guide the organization, right? So it will contain all of these. And we come to structural partitioning. See, when the architectural style of a design, it follows a hierarchical nature. So the structure of the program can be partitioned either horizontally or you do it vertically. So see, now you did what exactly is a control module, then you did the architecture, you did all the concepts. Now we come to partitioning. Partitioning is how you segregate the various modules. So that comes into structural partitioning. So the one way is to do you horizontally partition or you partition them vertically. So in horizontal partitioning, what you do, the control modules are used to communicate with between functions and execute the function. So it is in between the functions, and it has this fall three benefits that it provides, that the testing and the maintenance of the software becomes easier in case of horizontal partitioning, and the negative impact spreads slowly. Why? Because there are barcodes in between, or I would say they are different modules and they are separated by it, right? So the partition actually helps to um, actually delay this negative impacts like this. We can see, like as we are doing in COVID-19 also these days. So what we are doing in this, like the we are maintaining a social distancing, that is we are being partitioned, right? So this structural partitioning, so what this social distancing is doing, this is still like a measure to basically slow down this corona. We don't say that this is eradicating, but it is basically a preventive measure to just slow down. If you keep on like do not separate and you keep on being attached to each other, you can't you the disease will spread very fast, and it will be like you the human race may vanish also. But you are actually slowing the impact for the time being that you develop the medicine. So in anything that you do structural partitioning also, the anything that has to travel, any error that is being traveling or any bad effect that is being traveling, so this negative impact will be slowed by this horizontal partitioning, right? So the structure can be extended as easily, like you can keep on extending as and when you like. Beside these advantages, horizontal partitioning has some disadvantages also. It requires to pass more data across the module interface, which makes the control flow of the problem more complex. So you need to pass more and more data, so the control flow will become complex. This usually happens in cases where data moves rapidly from one function to another. In vertical partitioning, the functioning is distributed among the modules in a top down manner. So, what you do in vertical, you move in a top down manner, right? And horizontal is you move from left to right or opposite right to left. So, you're moving it horizontally. Wherein in vertical, you will be moving in a top up down manner. The modules at the top level are control modules, and they perform the decision making. Like we already did control modules, we looked at this control hierarchy. So the one on the top will be controlling the one below. So the upper one will be superordinate and the lower ones will be the subordinate, right? So all the decision making will lie with the control modules, and they do little processing. Whereas the modules at lower levels are the worker modules, and they are the one who are giving the computation and output tasks. They're the ones who are performing it. Only the decision lies with the control modules. See here, if I look, so this function 1 and this function 3, so there's the first diagram, function 1 2 3, this is all horizontal partitioning. So all of these are partitioned into horizontally, wherein if I look at downward chaining, the B part is the vertical partitioning, right? So the top one are controlling the lower one, the lower one are basically the workers, and the upper ones in hierarchy are the control modules. Next we come to data structure. See, a data structure is a data organization. We all know data structure. We studied the subject in detail also. Like I don't think that I really need to, but still, like for the since it's your syllabus, we can still give a revision to it. So a data structure is a data organization or management and storage format that enable efficient access and modification. So it provides you ample amount of opportunity to edit it, to modify it, to use it in a way that you want to according to your need or your problem. So, more precisely, a data structure is a collection of data values, the relationship among them, and the functions or operation that can be applied to the data. So, there are some data structure matrices to compute the effort and time required to complete the project, and their matrices are: first is the amount of data, the next is the usage of data within a module, the third is the program weakness, the fourth is the sharing of data among modules. So how many matrices are there? The very first is the amount of the data that you're talking about, right? So the amount of data that actually goes into is the one that decides this. Then we move on to the usage of data, that how it is being used within a module. Within a module, see, suppose if I am being enclosed into a position where and I am supposed to do I am, see, if I am in a control module or a below lower than that, so how my data is being used over there. So not even how much data, but also the use of the data, the way it is being used. Then there are a number of weaknesses into my program. So my programs will have a way lot of weaknesses. It can have, and there therein you decide that what kind I'm supposed to put in here or what I'm looking for in here. And how the sharing of data among modules, how these modules, the data is being shared from one module to the other modules. So all this will be kind of, these matrices are actually computing your time and effort, and time are being calculated to complete this project, right? So next we come to the software procedure. See, a software process model, this is a very specified definition of a software procedure, so which is presented from a very particular perspective. So these are see, my software procedure can be different from the way that the procedure that you are following. So this, I would say, this is not a particular perspective from, but I would say there is a personal perspective also in there. So every individual, every individual has his own style, and the procedure that he follows is actually mixed with his style of designing, I would say. So that software procedure is entirely dependent upon the individual who's doing it. So models by their nature are a specification, and so a software process model is an abstraction of the actual process which is being described. Process models may contain activities which are part of the software process, the software product, and the roles of people involved in software engineering. So there will be this what kind of activities will be the one that will make help me, like what kind of procedure I will be following. There will be software process, there will be a product, and how the peoples are being involved. So there are some process models I can say. So one, the first one being a workflow model. So this workflow model, this shows the series of activities in the process along with their input, output, and dependency. The activities in this model perform human actions. So anything that lies in between them will actually contain human actions. A data flow activity model. So this represents the process as a set of activities, each of which carries out some data transformation. So it shows how the input to the process, such as the specification, is converted to an output, such as a design. So this will actually tell you how the data is being modified from one state to the other state. The workflow was telling you the series of activity that you were doing in, right? How the inputs and outputs and the dependencies. Wherein the data flow will actually show how this in being converted from an output to input. So how your data transform one state of transition to the next state of transitions is the one that is defined by this. And they perform transformation are carried out by activities and people's different one. Then is a role action model. So this means the roles of the people involved in the software process and the activities for which they are responsible. So what roles the people will involve in the software process and what activities they are being responsible for. So all this comes into your software procedures. Okay, next we come to information hiding and modularity. See, this information hiding was the one that I started with, that is the abstraction concept. So information hiding is nothing but it is a principle wherein you segregate the design decisions in a computer program that are most likely to change, thus protecting other parts of the program from extensive modification if the design change is needed, right? So what you do in here, so the one that are frequently changing, right? So see, some kind of things change very frequently. So the I would say the entities that change very often are one separated from the lower level kind of an abstraction, so you don't need it, so you hide all those things. Wherein modularity is the degree to which a system component may be separated and recombined, right? So this we modularity we see when we did this, see, when I was doing about this partitioning and also about this architecture wherein I was designing into different modules. So in a similar way in here, what is a modularity is the degree to which a system's component may be separated and how they can be recombined. So that is modularity. So separated means what in, like I can say what individual work they perform, and when I say when they combine, recombining it, I would say how they how well they integrate to each other. So, a software design technique that emphasizes separating the functionality of a program into independent, interchangeable modules such that each contains everything necessary to execute only one aspect of the desired functionality. So, it should be one that if I want to perform, say, a specific task, if I have to say if I have to just calculate the salary of the employees, so only my salary of the employees would be touched, not my other sheets or my other modules would be touched. Say what are the what are their leave patterns or what are the kind of other things will not. So the salary modules will be just independent, and only it will have a calculation where it can have data, can take input data from others, and then it can compute to give the result on its own, right? So it execute independent of other events. So that is one big advantage of modularity. We can also look at it as a way of logical partitioning of the software design, right? So where you logically actually are partitioned it, like thinking actually give. So it's a very abstract kind of a concept, or I would say this is a very conceptual subject, right? Because in logical partitioning you are putting your conceptual designing and you're actually looking at it. So this allows complex software to be manageable for the purpose of implementation and maintenance. So what you're doing is that you're looking that if it is really like how good it is to implement and how good it is for you to maintain it, right? So the logic of the partitioning may be based on related functions, implementation consideration, data links, and other criteria. So that is very individual. I told you, when you were doing we were doing this architecture and the software procedure, that this is very individual taste like thing. So this will all be in this modularity also, that what the programmer or what the designer feels. So this is not exactly just the what he works to follow, that is of course there, but that also it will always have that user preference, or I would say the designer preference would be there, that how he designs it. So that's his way, that's his style will always be seen in this, right? So we have these important questions to define abstraction, modularity, information hiding, refinement, control hierarchy, software architecture, data structure, and software procedures. Right. So I think after this, all your things are clear and you have a understanding of how the processes are working. Okay. That's all for today. Thank you. Take care.